This webinar should give you some intuition what tasks are, how you can use them, and what you can do with them. It's not a tutorial, but still it will be probably pretty technical. So let's start with the agenda for today. We will begin with some task introduction to explain the basic concept and what tasks are. Then we move to the differentiation between tasks and activities, because these two are really close to each other. Then we will go through common type of tasks. We will mostly focus on tasks used for synchronization, because that's like one of the main purposes of tasks, but not the only one. And then at the end, we have two topics that are frequently asked by our customers, which is error handling and parallelization. So let's go into it. Let me start really from the beginning. You can imagine task as some logical unit of work. You have some work which needs to be done, and task is the thing that's executing the work and it's reporting the status and so on. So basically the task is representing the work. And there are two main types of tasks, synchronous and asynchronous. The trick is most of the operations in MidPoint are in fact a task. Even if you set up an email of a user or change it, this is executed as a task, but this is a synchronous task because it's executed immediately and you can immediately see the results in the user interface, for example. And this task only lives in memory, it's not stored anywhere, and after it's executed, you cannot interact with it in any way. So we don't usually care much about these, but it's good to know that even this is run as a task. Then we have asynchronous task, and this is usually something that we are interested in, because if you are executing some operation that takes longer amount of time, it's run in the background as a task, and you can check the results and see what's happening there. So example of this might be import of all of your users from your HR system, or even select 20 users and assign them into a role. And this is executed as a task and you can check the results later. There are two main variants of task. Either it's a single run, so I'm running single import, or I'm adding these users into a role, or it might be something periodical, something which is scheduled. And either is scheduled in an interval, something that you need to execute, for example, each minute or each hour, or it can be even set on an exact date, or repeating, for example, each Monday or so on. And then the task can be something that is easily executable, so it's like a single thread, and you don't worry much about the throughput or the performance. Or if you have really a lot of objects that you need to process, you can even run tasks in parallel, and we will get to this later, as I already said in the agenda. Okay, now let's move to task versus activity. Activity is something which is basically encapsulated in task. Activity is specifying the work that needs to be done. So as you can see on the picture on the right, we have example of simple activity, and we need to define what action, for example, recomputation of a user, and on what objects. It might be all users, or you can use query to select only particular users. And then as a part of the activity, you might define additional properties, like if the activity should be run in parallel, how it should be distributed across nodes, how errors should be handled, and also activity is responsible for reporting on the results on the individual objects, because the activity is really close to the work, so it understands what is happening, if there is a problem, or how to report the progress. And activity can be distributed to multiple worker tasks. So if we have task which runs in parallel, in fact, we have several worker tasks which are executed from the main task, and then the same activity can be carried over by this multiple task. On the other hand, task is an execution wrapper on top of the activity. So it contains like top overview, what is happening, like the whole execution status. Is it currently running? Is it stopped because there was some problem? Is it waiting to be scheduled? And so on. task is also responsible for reporting aggregated results to you. So give you an overview, what happened, how long did it take, and so on. And also the task is responsible for scheduling, and both time-based scheduling, like when it should run, and also scheduling across multiple nodes if you are running MidPoint cluster. And one task can contain multiple activities, so you can chain them in a single task. And also the activity can be really simple, as I illustrated here on the picture, or it can be composed activity, which is containing several work items that needs to be done. What is important is also the terminology, because when we are speaking about tasks, we are often referring to them by the activity. So if I'm, for example, saying reconciliation task, what I really mean on a technical level, it's a task with reconciliation activity inside it. But because we need to understand each other, and of course it's maybe more comfortable to just say reconciliation task or live sync task, we are usually using this terminology even in the documentation. But back to the tasks. I think one of the important things which might be confusing for some people is the execution status, and especially the first option, which is runnable. Runnable on task mean it's ready to be executed. So if the task doesn't have any schedule, it can be executed immediately when the scheduler gets to it. If there is a schedule, it's basically just waiting to be scheduled. So, for example, if you are uploading a new task into MidPoint from MidPoint Studio as an object, and there is no scheduling, and the task is in a runnable state, it will be immediately scheduled, because this is what the status is telling. Then we have running. That is obvious that the task is being executed right now. Waiting means the task is waiting for some resources or some dependency. So task might have dependencies on each other, so one task can wait for another task. Suspended means there was some problem during the execution, and it might be caused either on MidPoint side, for example, MidPoint was shut down or something like that, or it might be a result of an error with communication with a resource, for example, or even some configuration error which was executed by the task. And closed means the task is done. It won't be scheduled again. It's basically just waiting for some cleanup process to remove it. Then we will move to the individual type of tasks. And I will start with task for provisioning and synchronization, because this is a typical way how you are using task. And what is really important to know here, that provisioning as a way how to get the data out of MidPoint to some target resources is usually included in some other operation, in some other task. There is no separate provisioning task, with one exception, which I will explain later. So for example, if I edit a user in MidPoint and change an email address of the user, when I click save, the operation is immediately executing, including all provisioning where this new email should be provisioned. And same principle is if I'm loading some data into MidPoint. If I import a new user, of course it will import the user, create a user object if necessary, or update the attributes. But all these changes will immediately trigger provisioning to the target resources. And so the provisioning is really included in the operation that is actively executed. So this was like important principle to understand, because what I will explain later will really be based on this knowledge. So I will start with import task. This is like simplest task for synchronization. It iterates over specified resource objects. So usually when you are importing, you, for example, say, I want to import all accounts or all groups, something like that. Or even you can specify which resource object. And the import object is iterating over all of them, and then is synchronizing them. What does synchronization mean is defined in the resource. So we have reaction on the synchronization. What should we do, for example, if the account and user in MidPoint is not linked, or if there's if you synchronize the account and the user object is not there yet, it should be created and so on. This is configured only in the resource, and the import task is just executing them. And as I was explaining, this includes provisioning, because if I create, for example, a new user and it has some roles, should be provisioned, it's carried over immediately during this import. Then we have reconciliation, which is basically extension of the import task. So what does it do? It's iterating over all shadow objects that we have, and even over our resource object. And it's starting with pending operation. If there's some operation cache that is supposed to be executed but couldn't be, reconciliation will fix this pending operation first. Then it will do everything what import is doing. So iterate over all the resource objects and make sure all of them are synchronized. And then it will just iterate over remaining shadows objects in MidPoint, and usually just cleans them up, because if you have shadow object in MidPoint without actual object on a resource, usually it means it's a time to clean it up somehow. It's important to understand the purpose of the reconciliation. This task, its purpose is to make sure that given resource is consistent with MidPoint data. So if it's a resource which should act as inbound, we will just import everything to MidPoint, so that will assure the consistency. If it's an unbound resource, we will provision everything and make sure again it's consistent with the MidPoint data. And what is important to understand for even import and also reconciliation, that it's taking care of not only getting the data in, but also getting the data out. So even import task, its name might be confusing, but it's also provisioning the data if the resource is outbound, because MidPoint is always carrying inbound and outbounds together. LiveSync task is something that you are usually pairing with reconciliation, and its purpose is to monitor the changes in objects on given resource and just synchronize them. So usually you are using LiveSync for inbound, but again, if the LiveSync detects change on an account, it will load the change, so import the data, but it will also provision the data, so execute the outbound mappings as well. The purpose of LiveSync is, of course, not to provision the data out, but it's good to know that this is happening, because again, this might be tricky to understand. But the key functionality of MidPoint is it's keeping consistency all the way. So if you are loading some data in, that means you need to process them. That means they will be provisioned. That's the rule. And usually you don't care, because you don't combine like inbound and outbound resources that often. But if you have some resource which is, for example, mostly inbound, but you have like one or two attributes which is going outbound, it's good to know all these consequences. Okay, so that was tasks that were manipulating with external resources. And then we have something similar, recomputation, which behaves really close to the reconciliation, but instead of using external objects on a given resource, it's just using objects in MidPoint. So again, it iterates over specified objects in MidPoint. Usually you run this for all users, all roles, all groups, whatever is needed. And then synchronize them with all the resources. That means it will execute all inbounds and outbounds mapping for the resources when you have this object linked. So if it's a user for all accounts or inbound or outbound resources, it will run the synchronization and again make sure the data are consistent. So for reconciliation, we were given a resource. We were saying that its purpose is to make sure that MidPoint data are consistent with that given resource. Primary purpose of recomputation, that is to make sure that MidPoint internal data are consistent. And basically the provisioning that it is doing, it's a side effect. We are mostly trying to make sure that everything in MidPoint is consistent. And if you have some policy or some internal object mappings inside MidPoint, that is consistent. But as I was explaining before, one of the logic is MidPoint. If you know there was a change, it can be provisioned. Let's provision it immediately. There's no point of waiting for anything. So the recomputation, well, its purpose was to make sure everything is consistent in MidPoint, but in fact, it's just making the objects consistent also on the sources and target side. Trick part here is the configuration, because what I'm explaining is like standard behavior. But as you might know, in MidPoint, basically everything is configurable. And what tasks, what the synchronization tasks are doing, or even the recomputation, they are just using synchronization configuration for individual resources. So you should watch this closely for each resource, because it may impact how the tasks are behaving globally. Because yeah, the tasks are only executing what is configured elsewhere. And for example, you might have some dependencies. So the task, even if you want to execute it right now, might wait for a dependency. Or there might be dependencies between individual resources. Or for some resources, you might limit the propagation. You may say, okay, I just want to import the accounts now, but I don't want to propagate the changes anywhere. Usually this is not recommended, but sometimes you just need to integrate new resource very quickly and you cannot afford to wait for all the provisionings. So there are options like that. Or even there is an option telling, okay, when I'm importing for a given resource, I will just reconcile everything, all the resources, all the other inbound resources. So this was just some examples. So always watch the configuration, not only configuration of task, but also configuration of other objects that tasks are interacting with. And now I'm getting to one special task. It's called provisioning propagation task. And this might be useful in some corner cases, because as I was explaining, like this general principle is immediate provisioning. But there are some situations where this is not desirable. For example, your resource cannot process individual changes very fast. So, or there is some event after there is a change, you need to execute some process to properly get this change applied. So what you can do is to group some changes together. So you don't want to provision each individual change, but let's say provision each half an hour just to group multiple changes together. Or your resource is too slow. So for example, slow outbound resource might slow down your imports, and you don't want that because it's just slowing everything down. So you will say, okay, for this resource, do not provision immediately. We will done it in a separate way. Or you might have some problem with performance on the resource, so you don't want to stress load it, for example, during the workday. So you want to execute changes over the weekends or over the night. So these are some cases when this might be desirable. So what you can do is to configure resource to postpone provisioning actions. And then we have provisioning task, which will just execute all these postponed provisioning actions. So what is happening in the background, that the actions that should be executed are just stored in a shadow, and then the provisioning task will pick them up and execute them. And you can schedule the provisioning task anywhere you like. And so the provisioning task enables you to decide when it will be provisioned, and also it will decouple it from other actions like import. There are some other notable tasks that I want to mention. First one is validity scanner. This one is responsible for evaluating valid from and valid to attributes. So if you are set valid from, valid to, the validity scanner is basically querying all the object which have these two attributes set. And when you reach the threshold, so let's say you have valid2 and the current date and time will be after that, it will invalidate the objects. How it works, it basically used last scan timestamp, so it remembers when it was executing previously, and it will just take everything from that moment until now, and all what is in range in valid from invalid2 will be executed. You might think, what will happen if I right now, if I will change valid, let's say valid2 to yesterday's date, it will be executed immediately again, because if you have valid account and you will set valid2 in the past, it will be executed immediately. You don't have to do anything. If you set it in the future, it will be later picked up by the validity scanner. Yeah, and what is good to know here, the validity scanner is pre-configured. It's always there, so you don't even have to be aware. Maybe you are using valid from and valid2, and you don't even aware that the validity scanner is responsible for executing these changes. But sometimes you might want better performance on this task, so you can just edit it and, for example, configure it to run in parallel, which usually is not necessary. But in some cases, when you are heavily relying on valid from and valid2, it might be useful. Also, you might modify, for example, how often the validity scanner runs. Again, there is a default configuration, but you are completely free to change it. Same applies to the trigger scanner, which is a similar task, but instead of checking the validity of individual objects, it's just looking for triggers which are pasted onto objects. So in some cases, you don't want to execute some action immediately, but instead you will just put a trigger saying when this should be executed. And it might be useful, for example, on some error handling, or if you are working with some like a demanding operation which might repeat after a short amount of time, or if you are basically processing some events or messages. So instead of executing it immediately, you might just put a trigger saying, I will execute it in 5 minutes, and where the same action should be triggered again, you already know the trigger is there and you don't have to do it twice. So that's how these triggers are useful. And the trigger scanner, again, is a task which is just checking the triggers, checking if it's a time to execute the trigger, and executes them. And semi-validity scanner, even though in default it's like single thread, simple task, you can configure it to run more often or less often, to run in parallel, and so on, depending on your particular use case and on your needs. Last task that I want to mention is shadow refresh task. And this is a very simple task, which is just responsible to execute pending operations on shadow object or clean up dead shadows. Because reconciliation is doing the same thing, but this is quite heavy because it's also checking all the attributes, all the changes. Shadow refresh is really lightweight task, and if you have like a lot of pending operation or a lot of shadows that needs to be cleaned up often, it might be easier to run shadow refresh quite often, and reconciliation, for example, again, once a day, once a week, depending on your use case. Yeah, then moving on to some custom tasks that you can basically create. And example is a scripting task. And scripting tasks are used to execute like some custom or even usually bulk action. There are two types of scripting task. First one, like the old one, is non-interactive scripting task. And you basically have completely arbitrary script, which the whole task processing and execution doesn't understand. It's just script that needs to be executed. That means it cannot be optimized. It will just schedule it, run it, and whatever you write into the script will be done. But this is usually not recommended because we have a better way how to do things, and it is an iterative scripting task. And these tasks have two parts. First one is the script defining what should happen. And second is definition of input for that script. So basically query for some objects. So you might define this will run on all users from given organization unit, or on all rows, for example. And this is a recommended approach because with this split between the input and the script defining what should happen, we can do more with the task. For example, we can run it in parallel because we can separate the input into some parts and then let each worker node execute part of it and then put it together. Or it's even able to report the progress, because on the non-iterative scripting task, the MidPoint cannot understand what's happening inside the script, so it can just say it's running or it's not running. Here, because we have input and it's iterating over the input objects, it can report you, for example, I'm processing 50 objects out of 100, so you even know what is happening. So this is the recommended approach. Moving to error handling. So we have two types of error that needs to be handled. First type of error is something that is affecting the whole activity. For example, the resource is down, it's not available. And there's not much that can be done in this case. Well, MidPoint can just suspend the task, and the best strategy is to either let someone examine what is happening, and then to reschedule it. And you can even automate it with some external tools if it's needed. So what we are going to focus on today is how to work with errors that is affecting individual objects. Because there we have several options how to handle this type of errors automatically. So we need to first understand what is happening there. So we have different type of situation. Either this is reported as some partial error, or it can be reported as a fatal error. And then the errors are differentiated into categories like network error, security errors, policy type of errors, and so on. But this, if you are having a task which is working with some resources, it's really heavily depending on the support in the connector. So if the connector is properly written, it can also properly report the errors which is happening there. But if the connector is poorly written, for example, everything can be reported as a generic fatal error, and then you cannot do much in that. And of course, the error, for example, the configuration or policy error might happen inside the MidPoint. That should be always properly reported. Then you can decide what you will do with these errors. So usual reactions, and we are talking about errors on processing individual objects, is to ignore them. Because, for example, you are running import task, you will ignore these individual errors, and then the import task will just provide you a report. How many and which accounts, for example, were synchronized correctly or imported correctly, and which were ignored. There was some problem, and then you can reschedule, for example, or we will get to this later, how you can deal with that. Second reaction is to stop. And this is default for live synchronization and asynchronous update, because in live synchronization, you probably want to process the objects in order. So if there is a problem, you want to stop, figure out what is happening, and then continue. But of course, in some cases, you can override this, and let's say even for live synchronization, you can just ignore this because it will be solved later. Last option, which is not by default and is only supported for the synchronization activities, is to just retry later. So if there's a problem, just schedule something and retry later. And I will go into details on all this situation. So first, the ignored situation. And first option how to deal with that is just to completely ignore it, because it might be solved in the next run. For example, if I'm running reconciliation, it will reconcile all the accounts anyway in the next run. So even if there's a problem, if the root cause of the problem will be fixed until the next run, Next time, it just make sure it's consistent with data in MidPoint. But in this case, what I can recommend is to have some monitoring, because if there's that problem again and again and again, you want to know that the reconciliation is failing, and it's failing maybe on the same account, so that account is not synchronized at all. And again, this monitoring can be external using some of your favorite tools like Nagios or Singa or Zabbix. Or you can use even MidPoint functionality and set up some reporting or email notification, up to you completely. Or what you can do in this situation is just rerun the task for the failed objects. So what is supported here, you have an option how to specify which objects were failed, or there was some error during the processing, and use them to create a new task which will fix them somehow. And either it can be the same task, for example, you can run just the reconciliation again for these accounts, or even you can define a custom task. So it might be some bulk action when you will write custom script telling MidPoint exactly what should happen. And again, this is specific because we cannot know what type of errors you will encounter and what you need to do. So the MidPoint is just supporting you to select the failed objects. And you can, again, use the type of errors that I was explaining before to define which objects should be selected, for example, or object where was network error there, or just partial error, not the fatal errors. Or you can even select based on the time constraint, like when the account failed. For example, you want to run this only for accounts that failed in the last 24 hours. All of this is possible, so you just select the objects and define a new task, which will fix them somehow, and it's up to you what task it will be. It is quite complicated, but on the other hand, it gives you enough freedom to do whatever you need. So second situation was the stop situation. This is usually for live sync or asynchronous task, because in this case, usually it requires some manual intervention. You want to understand what happened, especially on asynchronous processing, because if you lose one message that should be processed, you have no consistency anymore. So usually what is recommended to do is just to figure out what was wrong, fix it, fix the source, fix the message itself, fix the configuration MidPoint to process it properly, and just continue with the live sync or asynchronous processing task. So it's recommended, but sometimes you cannot do it. So you can fix the problem on some bigger scale. For example, let's say you will do a full reconciliation to make sure that, again, the source of the events and MidPoint is consistent. And then you will just reset the token for live sync to start from the current state, or clean all the messages queue and start again. So this is the reason why we usually use stop, because you want to figure out and make sure this will never happen in the future. And this is the usual problem, especially with the asynchronous processing, because you have just stream of events, and it's really hard to debug errors there. On the live synchronization, this is usually easier because the live synchronization always have the full status of the given object, so it's easier to debug. Yeah, but as I was saying, fix the problem, resume the task, or somehow fix it globally, fix all the object, make sure everything is consistent, so reconcile it, then reset and start from the current state. So this is the recommended approach. Last but not least, retry later situation. And this is the easiest way how you can handle errors. But there is a limitation. It works only for shadow objects and synchronization tasks. So for reconciliations, for imports, for live syncs as well. And it's really simple. Only thing you need to do is to configure scheduling. So basically to say, if there is a problem, try it again, 5 minutes, 1 hour, 1 day, whatever you need. And that's it. Rest is carried out by a trigger scanner, because when the error happens, the synchronization task will just put a trigger on a shadow object, And then trigger scanner will find this trigger and execute it. So this is what I'm recommending you to start with, because it's really easy. You don't have to think much how you want to do it, and everything will be done automatically. But of course, if you have complicated situation, you can use the other option that I was already describing. Last thing on my agenda today is how to deal with parallelization of task. Because sometimes having everything run on single node and single thread is not enough. You need to scale, you need to process more accounts, more objects in a shorter time. So we have two ways how to deal with that. First one is multi-threading, which is supported by LiveSync, for example. And second option is to run tasks on multiple nodes. And all type of tasks that supports to be run on multiple nodes also supports multi-threading. So from those we were talking about, it's a recompute, reconciliation, import task, iterative scripting task, validity scanner, trigger scanner, shadow refresh, and even propagation. All these tasks are support multi-threading and multi-node. LiveSync supports only multi-threading. It cannot run on multiple nodes at the moment. But all these details, and if you need to deal with different tasks that I didn't mention today, everything is very well documented in our documentation. So how does multi-threading work? That means that you have a single node, but you have multiple CPUs, or you don't even have to have multiple CPUs, but you can run multiple threads. So, and if you are on the multi-node setup and you want to have multi-threading as well, then you're just defining how many threads will run on each node. The configuration is really simple. You just put a one number, and this is number of threads. You will put it into a task configuration. So if the task is supposed to run on a single node, it will be number of threads. If it's a multi-node task, this number say number of threads per node. This is important detail to know. And as I was saying, it's configured in the activity distribution section in the task. And it's not supported for all activities. It's supported for those which are named on the previous slide, and you can check always the documentation for the details. It's very well documented. Multi-node parallelization is different way how to scale it. So if you have a cluster setup of MidPoint, you have multiple nodes, you can even distribute load to multiple nodes. As I was saying, you can combine it with multi-threading, so you can distribute it over the nodes and run multiple threads on each nodes. And to be able to use this, you need to define, we call it buckets. So you need to split the items that needs to be processed, for example, the user objects or the accounts or rows, whatever you are processing, into some buckets, and these buckets are distributed across the nodes. And I will explain these buckets in a moment. Also, what you can do is enable auto-scaling. This is really simple. It's basically a simple parameter just to enable or disable this. And where the auto-scaling is enabled, the load will be automatically distributed to all available nodes. So if you just add more nodes, the next execution of the task will be distributed across multiple nodes. What is not supported now if you change the number of nodes during the task execution. If you are adding them, that's easy because they won't be used on this run and will be used on the next run or on another task that are being scheduled. If you are removing some nodes where the tasks are currently running, of course, this part of the task will fail and you need to re-execute it later, for example. And again, multi-node parallelization is not supported for all activities. For example, for LiveSync, it's not supported. Check the documentation for details for which activities this is supported and for which is not. So the buckets definition. This is very important if you want to run multi-node task. What you need to do is to find a way how to split objects that needs to be processed into roughly equal size sets. And for this, we are using a process, we call it segmentation. So you need to find a property. Based on that, you will split it into these buckets or sets, or how do we want to call it. And we support different type of segmentation. For example, numeric. If the object has some IDs, ideally sequential or evenly distributed, you will just say, okay, let's use this numeric attribute, and it's starting in this number, ending in this number, and we want to split it in a groups by thousands of objects, for example. That's easy. You can do something similar with strings. So for example, let's split it based on the first letter of the username of the users, or first two letters, something like that. With OIDs, basically OIDs is just a string, but some kind of limited string, so it's using the same principle, or you can even put a custom formula there. Why is it so complicated? Because you can imagine that, of course, MidPoint know which objects needs to be processed. It can just load them and distribute them. But technically, it's working on a different principle. Basically, this segmentation definition is just passed to these individual nodes, and the nodes are querying the objects. Because if you are working with external resources, even querying the objects is costing you some performance. So it's better to just distribute the query than to distribute the objects. So you will just say, okay, for first node, you will process every user starting with A. Second node will process every user starting with B. And then you schedule the work like that. And each node will just run a separate query, gets only the object that's supposed to be processed by the node, and the performance is higher that way. But what is the hard part of you need to define the segmentation. And to be able to define it, you need to know your data, because nobody knows your data. Someone is using, for example, numeric identifiers, but they are starting from 1 million. So there's no point in creating a bucket for anything lower than 1 million. And so on. You might use strings, but for example, your strings, you are using something like OIDs. So A to F is a good prefix for creating a bucket, but for example, Z or Y, there's no objects in there. So you need to understand what your data are and define the buckets. And I was saying you ideally aim for roughly equal size of the buckets, but it doesn't have to be exactly. It's just used for the distribution. So in the worst case scenario, the last bucket will be the big one, and one node will just take a long time to finish the processing, but otherwise the work will be distributed anyway. And again, if you are working with resources, you need a connector support for that, because at the end, the query, for example, give me all the accounts with usernames starting with A, needs to be executed by the connector. So the connector needs to support this type of query, but proper connectors should support this. So at the end of the parallelization section, I would like to give some recommendation. And the unfortunate truth is there is no silver bullet. It's all depending on your environment. It's also depending, for example, what are your bottlenecks? Are you need to just improve your throughput, so you need to process more objects in a shorter time, or you are dealing with slow resources, so you want to just run multiple threads and kind of eliminate these delays. And based on that, you need to set your scaling. Because, for example, if I know my biggest problem is network latency, I can run multi-thread task way over, with the number of threads way over the number of my processors, because I will be waiting for the network anyway. But if I just want to optimize throughput and all my resources, network, everything is perfect, I want to get as close to my number of processor or to my number of nodes to really just use the physical hardware as much as you can. So you need to understand your environment, what your bottlenecks are, and set your scaling distribution accordingly, and also set your bucketing so to understand your data as well. And this auto-scaling feature that I described can be, for example, used very well with some external monitoring. So you can monitor the load on the CPU, for example, and when the load is too high, just start an extra node, and so on. But again, it's mostly up to you to know your environment, to know what you need to optimize, when you need to optimize. And I know it would be better to have some like magic that would be automatically take care of this, but unfortunately it's not that simple. So it's really relying on your knowledge, but with proper setting, you can really increase performance by a lot. So to conclude, I give you some overview of task. Hopefully you have this better idea how task and activities inside works, how you can use what is possible. All the details are in the documentation. Today, I just want to inspire you to tell you what you can do. Maybe you were not aware of these details and how you can configure it. And if you have some corner case, usually there is some option for that. So check the documentation and you will find all the details there. I didn't cover all the options, what you can do with the task. For example, I didn't cover task chaining, so let's execute one task after another. I didn't go through all the various synchronization options, which are not exactly defined in task, but are heavily relevant to the task, to the synchronization task, of course. And as usual, your feedback is welcome. So with this, I would be really happy to start a discussion, and I would be happy to accept some feedback. We can discuss what features you are missing, what you like to have, or you can have questions to anything that I just presented.